Welcome, everybody. Welcome to Vancouver. Hope you're having a great conference. Today, we're going to talk about VNF onboarding. Before I get started, though, I just want to get a few logistics down. If you do have questions, please save those for the end of the presentation. We've reserved a little bit of time at the end of the presentation so we can answer any questions that you may have and engage you in some discussions. There are 2 microphones in the aisles. Please use those so that we can capture your questions for the audio on the video. That would be great. My name is Pete Bry, and I'm with NetApp. I'm responsible for our open ecosystem marketing. This involves our OpenStack efforts, as well as our DevOps efforts and our containers efforts. So any of those 3 topics in the next hour and a half to 2 hours, we're going to be in this room talking about various different topics and how NetApp is engaged with the OpenStack community. And that's a great segue into what I want to talk about. First of all, you might say, well, who is NetApp? If you haven't heard of us, we're a data storage company. And in fact, we've made significant contributions to OpenStack over the years. Ever since 2011, we were the original PTL for the Cinder project, as well as PTL for the Manila project, too. We continue to make significant contributions to the code base and continue to support both from an engineering perspective, a marketing perspective, and working with customers and partners like yourselves to use OpenStack for innovative solutions. Today we're going to talk about NFV, and we're going to try to, hopefully for some of you, clear up or maybe answer some questions that you may have. I have 2 esteemed guests with me from a partner of ours called Interdynamix here in Canada. And they'll be talking in a little bit more deeply about NFV and VNF onboarding. At NetApp, we have a full portfolio of data storage products that interoperate with OpenStack. Everything from our innovative solid fire solutions, which were purpose-built for OpenStack environments to scale and deliver the on-demand performance that you need for multi-tenant workloads. We also have our ONTAP platforms, which deliver feature-rich data services. So if you're dealing with mission-critical applications and you need redundancy, our ONTAP solutions are the best at that. And then we also have our E and EF series, which are really optimized for mass storage solutions. Also not shown on this slide is our storage grid solution, which is an S3-compatible, Swift-compatible object storage platform. As I've mentioned, we've contributed in many, many different ways to OpenStack. I mentioned our PTL leadership for both Cinder and Manila, but we're involved in a lot of different projects within the OpenStack community. And that's not the end of what we are involved in. We work with all of the major distributions. We also have developed numerous different reference architectures with different partners, with Red Hat, with Cisco, SUSE, Ubuntu, you name it. And we also have done a lot of work, I mentioned DevOps earlier, a lot of work in automation around Ansible, Puppet, and other tools to automate your environments. So we're very committed to this entire ecosystem, open ecosystem space. But like I mentioned, what we're going to talk more deeply to you about here today is our involvement with NFV. We do work with many different customers around the world on developing these types of solutions and using our storage and our platforms as part of their overall architectures. You may have heard of the NetApp Data Fabric. This is essentially a way of deploying our storage systems, but being able to migrate and move data within those subsystems seamlessly. This delivers the scale and the zero-touch automation that you need, and it also delivers the performance too. Let's talk a little bit about IDX or Interdynamix. And today we have Kevin Schmelz and Curtis with us. And Interdynamix has been working with NetApp for quite some time. They bring to the table really 3 sets of capabilities that really help us in understanding the unique needs of these NFV solutions. They possess the understanding of the marketplace and the requirements. They have the relationships with individuals like yourselves to be able to design and build solutions that solve the real-world problems. And as both Curtis and Kevin will get into here, it's fairly complex solutions, and they'll talk more about that. But what IDX can do for you is it can really help you from day 0 to architect the right solution. But it doesn't stop there. When you actually want to deploy, they can help with deployment services too, day 1. And then this is where they really go above and beyond, is ongoing support for operation and maintenance of these solutions. So what I'd like to do is turn it over to Curtis and invite him to come up here, and he can talk more deeply about NFV, and then Kevin will talk more about VNF. Curtis.
Okay, thank you very much.
Mm-hmm.
So what I'm going to do is basically set the stage for Kevin. I'm going to give you a bit of an introduction to network function virtualization, and it's quite possible that a lot of you in the audience have seen some of these slides or have a pretty good understanding of NFV, but I'm going to kind of give a little basic introduction to it, and also in the end start to discuss some of the complexity that causes problems in terms of we have all these pieces of infrastructure that we need to manage. And that's challenging enough. And then once we have all that working and there to be used, we still have to go through the whole process of actually bringing VNFs, onboarding VNFs, running them. So there's just a ton of complexity here. What is network function virtualization? At the most simple level, what we want to do is take a physical network function and make it virtual, right? And when we do that, we make it a virtual function, and we put it into some sort of common infrastructure, like a network function virtualization infrastructure, which is typically, in the context of where we are today, OpenStack. Generally speaking, OpenStack is probably the de facto standard for network function virtualization APIs, right? So, at the most simple level, all we want to do is virtualize a physical network function. So what are some benefits? I put a few benefits up here. These are some pretty common things that people, if you've been familiar at all with NFV, you've seen these kind of things before. But the one that I really like, which I kind of put in quotes because it's a funny word, but softwareization, right? Kind of my opinion on this is that what we want to do is turn a lot of this infrastructure into a library, because we're gonna, as Kevin will talk about more, we're gonna program network services. We have to write code, templates. It's not necessarily it's a domain-specific language. It's not necessarily an obvious programming language. It's more like a template, but we have to write those templates and bring them into our system in order to actually deploy these network services, which is the entire goal, right? We need all this infrastructure, all these APIs, all of this automation-capable infrastructure to deploy a network service. That's our end goal, right? That's what we want to do. We don't want to worry too much about all the other underlying stuff. We want to actually deploy our service, right? So I kind of feel like the underlying infrastructure should be almost like a library, right? We can almost consider it a library for these VNF templates, right? So we may have seen this diagram many times, but I always like to kind of go over it because in the red box here, so this is the Etsy diagram that, it's almost like a traditional diagram now, where it describes what network function virtualization, what the pieces are, what it looks like, what makes up this system, right? So in the red box, I have what's typically considered where OpenStack tends to be, right? So OpenStack has APIs. It has a scheduler that's usually considered to be the VIM, the virtual infrastructure manager. And then we have the actual NFVI, which is typically considered to be the storage and the compute and the networking, those resources that we use to actually deploy VNFs. So one of the pieces that we need in order to actually deploy a network service is some sort of VNF Manager or management and orchestration system, right? So there's commercial ones, there's open source ones. Some are simpler. We did a demo earlier this week using Baton, which has a pretty small code base, and some are more complicated, like ONAP, which I believe when you deploy it using their heat version templates, it's between 17 and 33 virtual machines, right? That's what's required to deploy ONAP if you use the virtual machine. You can also do it with Kubernetes, but it's a very large, massive piece of software, right? So there's a lot of complexity there. I also have the squiddy-looking one is the attacker project. So there's a generic sort of VNF manager that's under the OpenStack umbrella called Tacker. I'll pop back to this diagram, but all these pieces actually mean something, right? So it's really easy to look at this diagram and go, okay, well, it's really busy, I've seen this before, but these pieces actually mean something. So I just kind of wanted to give you an idea of what a lot of these acronyms mean, right? So I mentioned the VIM, the Virtualization Infrastructure Manager, the NFVI, element management systems, management and orchestration, these higher level abstractions that do all of the automation, right? So all of these pieces mean something. But what is the network service? What are we actually trying to deploy? And I think one of the easier ways to think about it is that we're going to deploy a bunch of virtual network functions and string them together into some kind of chain, right? So it could be, some people might use the term service function chain or graphs of some kind. But what we really want to do is deploy a service to provide functionality to a customer, right? So, and that's what we're going to do when we onboard a VNF and bring a network service online, is we're going to create some sort of collection of network resources together. This is just another sort of depiction of the same concept. This is one taken from one of our blog posts at Interdynamix on service function chaining, right? So service function chaining is a pretty interesting topic that I'm quite interested in, because you can take, depending on how you do it, you can take a collection of VNFs, string them together, and you can almost magically make packets appear on interfaces. And it's very powerful because we can switch, we can automate, we can move things around, we can almost instantaneously change the chain that makes up a network service, right? So in this instance, we have a traffic red and a traffic blue, but we could almost instantaneously switch those around and make changes to them. I mentioned Baton. Baton is really interesting because it is a reference architecture for the diagram that I kind of showed before at the management and orchestration layer. So it's made up of a NFV orchestrator, a generic VNF manager. There's also other capabilities that you can use, like auto-scaling engines and fault management libraries. I mentioned the presentation we did earlier this week about network slicing. There's a network slicing engine. So it's a pretty useful tool to examine how you might use a management orchestration layer, because it's as I mentioned, it's quite small, especially compared to something like ONAP. This sort of describes some of the pieces that I already mentioned. We have the network slicing engine, a VNF Manager, the NFVO. These are the pieces that make up a typical management and orchestration layer. Recently, and ETSI-OSM released a white paper just this month that sort of describes some of the work that's being done around the interfaces. So this diagram is very similar to the first one that I sort of referenced, but it's also describing the interfaces, like the connections between the different pieces. So there's been just a lot of work done around that area, because it's not just these blocks, but it's also the lines between the blocks that matter. So in order to do VNF onboarding, we need some sort of language to describe the network service and the VNFs that make up that network service. So typically speaking, Tosca, this topology and orchestration specific for cloud applications language, which is a domain-specific language, has been created so that we can do just that, right? And this is what Kevin's going to get into in the rest of the presentation. But I think if there's anything that I wanted to really make a point of, is that there's a lot of complexity here, right? So with a NFV infrastructure, like, you don't have to have an SDN, but you probably will. OpenStack, it's had a sort of history of being extremely complex. So this is like the diagram on the left side is like a kind of a traditional diagram that you would see for OpenStack. It's been around for years. It's not necessarily accurate anymore, but I just wanted to use it to describe like how complex these systems are, right? And then the diagram on my right here is just an example of Open Contrail, right? So there's all these different pieces and all this extra complexity, you know, that we have to deal with just so that we can get to the point where we want to do VNF onboarding. And the same, I mentioned ONAP. So here's another diagram of all the pieces that might make up ONAP, right? So this management and orchestration layer, very complex. You know, it's probably as complex as OpenStack almost. There's all these moving pieces, all these moving parts. But we probably need the SDN. We definitely need the NFVI. There has to be some sort of management and orchestration layer. We have to deal with all this complexity. And then once we have that, then we can finally do VNF onboarding. And I'll pass it to Kevin at this point now to describe that part.
Thank you, Curtis. So a few minutes ago, Curtis talked about some of the very important benefits that service providers are looking for in NFV. Problem is, early adopters are not finding those benefits. At least they're not realizing them to the degree that they were expecting. So why is that? Well, as Curtis has talked about kind of throughout his few slides here, it's too complex. The complexity is getting in the way of them realizing their benefits. It's increasing the cost, and it's delaying time to market, so it's a problem. That complexity comes kind of in two different areas. The first is design and build, and the second is operating the thing once you've built it. So on the design and build side, it really starts with the fact that it's OpenStack, and OpenStack is a complicated beast. A lot of pieces to it, a lot of vendors that are contributing to it, a lot of integration points, and it's rapidly evolving. It's evolving technology. And on top of that, there just aren't enough of you guys. It's hard to find enough expertise to be able to build these things. Once you have the platform built, though, some would say the real hard work actually starts, which is onboarding the VNFs and writing the code that's required to make that happen. And I'll talk, for the most of our remaining time together, I'll talk about that. But before I go there, I do want to address the operational complexity as well. And again, there are two factors leading to operational complexity. The first is the nature of the networks that we're building on NFV. These networks themselves are highly virtualized, and they're very dynamic. And so what that means is that troubleshooting these networks, applying the same tools that were used in physical networks and the same techniques, not so effective anymore. So we need to find new ways to manage these networks and to troubleshoot them. IDX is actually doing some research in this area. It's one of the main areas of research we're working on right now around orchestration. And so that's things like finding orchestration components and tools. That's a great example is we're looking at how machine intelligence can play a role in orchestrating networks. The other operational challenge is keeping the platform itself stable and secure. So with so many components and so much continuous change, again, the old way of doing things where we took a bunch of patches and a bunch of upgrades and packaged them up together, tested them, and then deployed them into production maybe a few times a year, can't do that anymore. That's not acceptable. We need much more like a DevOps type of approach to managing these platforms. And so on that front, IDX is actually working with Red Hat as a partner in their DCI program, Distributed Continuous Integration. And what that brings is a CI/CD pipeline, continuous integration, continuous delivery pipeline, and a more agile way of maintaining these platforms for our clients. So why is VNF onboarding so complex? Well, it starts with the fact that there isn't yet a lot of standardization around how this is done. Each VNF kind of has its own API for lifecycle management. In fact, it has its own approach to lifecycle management. There are different ways that the whole NFV solution can work together to manage the life cycles of these VNFs, and that's not yet standardized. The second reason for the complexity is the number of integration points. Curtis showed you some diagrams of NFV, and there are a lot of integration points. each VNF has to communicate with the infrastructure it runs on. It has to integrate with other VNFs that form the overall network service, and it has to integrate with management and orchestration. So all of those integrations have to be dealt with and have to be tested. Putting all of that together and all of this complexity, and then add to that, by the way, the fact that for a network service to be useful, there has to be a way for a service provider to actually provision that network service, and that requires yet another integration from OSS and BSS systems to the NFV. And so that leads to a lot of complexity and a lot of cost and risk, in fact. Let's take a little deeper look into the steps of onboarding to just get an appreciation for what's involved. So the first thing that has to be done is we have to procure the package that is the VNF. And once we get that package, we need to validate that it actually came from the right place and that it hasn't been tampered with, all the kind of basic security and integrity stuff. Having done that, the coding begins. So we write these things called VNF descriptors and various other code that's required to do a couple of things. It has to mate a VNF to the underlying infrastructure, and it has to tie the MANO to that VNF. So back to these unique APIs, we have to provide a way for the MANO to talk to the VNF directly or indirectly in order to instantiate it, in order to do scaling operations, to get metrics from it, and so on. So we get that done. Now we have to test the basic functionality, which is kind of like a smoke test at this point, just making sure that the VNF does what we expect it to do at a very high level. Then we can go on to do some lifecycle management testing, making sure that those integration points we've created are effective and they work properly, that the VNF Manager can actually instantiate and scale that thing. Then maybe the hardest test is the performance testing, because we have to ensure that this thing is going to scale to the level that we require from a performance perspective. Good, so now we have a single VNF that we know performs well, that does what we want it to do, and we can control it. However, we're still not really providing a network service, so we have to go to the next step, which is to tie a number of VNFs together into a network service, which is more coding. We have to write VNF forwarding graphs, we have to write network service descriptors. All of these templates and all of this code that ties the individual VNFs together into a concerted network service. And then we have to test that network service. We have to make sure that, A, we can instantiate that whole service, all the VNFs are going to participate and work properly together, and that we can, in fact, do it in a timely manner. So IDX is working with an organization here in Canada called CENGEN to write some methodology around how all this VNF onboarding happens. Just a little bit about CENGEN. The Center of Excellence for Next Generation Networking is a group, it's a consortium of virtually all of the major service providers up here in Canada and a few NFV vendors. And their mandate is to foster innovation in network technology. So a little bit of history. A few years back, we had companies like Nortel, we had Newbridge, and various others that were world leaders in network innovation and research and development. And some of those companies no longer exist, and with their demise, Canada's place on the world stage of network innovation has sort of taken a bit of a dip. And so the founders of CENGEN wanted to reverse that trend and bring Canada back into the forefront, so they created this organization. Now we're working with CENGEN to, as I said, develop a methodology, but that starts with a couple of test methods, and we focused in on what probably is one of the more complicated pieces to start with, which is performance testing of the data plane. So more specifically, in our first project with CENGEN, we created two test methods. The first is to do what's called benchmarking, and what that really is, it's we fix the level of resources in the NFVI, the NFV infrastructure, and then we solve for the level of performance that we can obtain using a VNF that's under test, a VNF under test. The second test method is kind of the reverse of that, which is called dimensioning, and that's where we fix the level of performance that we require from the VNF, and we solve for the level of resources that are required of the NFVI. So that was the first project with CENGEN. Now we are about to kick off our second project, which is to take those methods and utilize them in a real-world situation to generate a test plan, to generate test cases, and then to execute against that capturing data and meaningful information about those VNFs. So the second project will be considered a success if, in fact, we can use those test methods to do all that stuff and end up with, with results at the end of it that include the level of performance a VNF is capable of and some dimensioning results for our NFVI. Going forward, the expectation is that we continue to work with Sengen and with other partners building this methodology for VNF onboarding, which helps to simplify and standardize that whole complex process. So Curtis and I have both talked quite a bit about complexity and the fact that there's some disillusionment right now around NFVI and the benefits that can come from it. But at the same time, those benefits are just too important to ignore. And in fact, NFV has a role everywhere from the CO all the way out to the customer premise when it comes to service providers. And in fact, I don't think anybody really believes that with things like 5G and the Internet of Things and the stress that those are putting on networks and the demands that they make of networks, that there's really any option here but to do NFV. So it's not a question of whether we do NFV, it's a question of how do we manage that complexity and how do we deal with some of the challenges. And so we will do that. And as we do that, NFV is also going to expand beyond just service providers and move into other industries. In fact, according to a couple of surveys, more than half of industries other than service providers are already looking at an NFV strategy. They might not think of it as NFV, but under the covers, that's what it is. And so that might take the form in other industries of things like universal customer premise equipment, where we can put some infrastructure into a remote office and set some VNFs on top of there, things like load balancers and routers and so on, and centrally manage that. So again, too much benefit to ignore. It has to, we have to solve the problems and do this. So the second thing that's going to happen as we solve these problems is disaggregation. Right now, most of the VNFs that we're seeing are really almost a lift and shift. We take the physical network functions from vendors, and the vendors are simply re-implementing that in software to run on x86. And that's great. But as we go forward, what's going to happen is we'll see those network functions being broken down into their components. And why do we do that? Well, the biggest reason is because as we break it into its components, it gives us much more granularity in the control of those things so that we can scale out and scale in individual components, making much better use of our resources. Thirdly, we'll see containerization of VNFs. It's already started. There are quite a few VNFs available now as containers, but we'll see more of that. And again, there are two reasons for that. The first being more efficient use of resources, of course. But the second is that we can spin up a containerized VNF much faster than we can one based on a VM. That's important in the auto-scaling scenarios because the time to react to changing load conditions is very important. And while spinning up a VM and configuring it, loading a VNF on top of it, that's fast, but it's not instantaneous. So containers help us to do that better. Fourthly, as we move from hardware design and development, which is very expensive, into software development, which is still expensive but arguably less so, the barrier of entry drops, and in fact, theoretically, any application development shop can become a builder of VNFs. And so as that happens and we open up the market to more participants like this and the barrier of entry drops, we're going to see more and more specialized VNFs that we never would have thought of implementing on hardware before. So we'll see things, for example, like highly specialized security tools that are designed to thwart one very specific attack. We'll see machine intelligence functions that have one task in an automation environment, for example. So we'll see specialized VNFs entering the market. And finally, we'll see some standardization. So Curtis referred to a white paper from Etsy that was released, I don't know, a week ago or something like that, very recently. And in that white paper, there was a quotation that this whole process of VNF onboarding can never be automated because it's too non-standard. And that's true. However, pieces of it can be automated. So for example, the generation of these templates. We can build tools, and we will build tools that help to automate that, improving the consistency and speeding it up and making it more economical, solving the complexity problem. We'll also see some standardization on the APIs themselves. They'll never be completely standardized because there's too much variation in the functionality, but we will see some consolidation of that. And we'll certainly see some consolidation in the approach that's taken to lifecycle management for VNFs. So we will see increased standardization. At this point, I'd like to thank our NetApp partners for inviting us to talk here, and thank you for your time to listen to this, and invite any questions.
So can you explain how the VNF providers get paid for the service they're providing? The application itself, is it a, how are there methods to basically bill the service provider for the functionality?
Wow, great question. So that's one of the areas of complexity all by itself. How they get paid, the licensing models are completely non-standardized. They're all over the map. There are many different answers to that question. And that is another one of those things that needs to be standardized so that we can understand the true cost of NFV solutions.
Are there any production deployments of this anywhere?
Yes. I can't really talk about them here, but yes. Yes. And what we're going to see is, right now we're starting out with fairly simple network services, but those are going to become more complex, involving more and more VNFs, which is just going to add to the complexity challenge.
Yeah, as you've said, today vendors implement VNFs in very different ways, and each VNF is very complicated. Sometimes it could be, 10 virtual machines, whatever, for a single function. So that's going to make it very hard to integrate. Now, you said some aspects will be standardized. Can you elaborate on what parts those are? You mentioned a little bit, but can you expand, as time goes on, as VNFs get disaggregated, what aspects of onboarding and deployment will get more standardized?
Well, probably all aspects to some degree or another. So for example, the hand coding and the template generation will become automated, but the APIs themselves will probably be more consolidated. We'll settle on a smaller number of ways to do the lifecycle management and a smaller set of APIs. We won't get to one, but we'll get to a few.
Sorry, for doing this, do you guys rely on standard neutron networking, or do you still require things like tungsten fabric, Juniper Contrail, MonoNet to do the service function chaining?
It really depends on the problem to be solved. Both of those are very valid solutions.
So how do companies begin to work this problem? Is there a common shared lab environment for collaboration, or is each company working independently to try to solve this problem?
So by each company, did everybody hear the question? Okay, by each company, do you mean the VNF vendors?
Well, the whole ecosystem.
Yeah, so the whole ecosystem, there are shared labs available that are being used to help solve this problem. But there are many, many players that are working on solving the complexity. Yeah. A great start would be, let's talk offline, and I can get you a list of places to go.
Did everybody get a blue ticket? We're going to be wrapping up here. Thank you so much, Kevin.
Thank you. Thank you, everyone.